These are the essential questions and sentence stems for the week. Pause the video to read over them, but they are also available on your Math Blend page. Here is the vocabulary for the week. Feel free to pause the video to read over the words and see if there are any you may not know. Okay, so multiplying tens. Anytime you're multiplying, it is really just a repetition of addition. You know how to add, it's just adding multiple times. Division we'll get to in 2 weeks, just later down the road, will be to subtract multiple times. But multiplying is adding groups, right? You have multiple groups, you're putting them all together, you're doing it quickly. So let's do some random facts. If I were to have, let's say 3 times 10, this would mean that I have 3 groups of 10. So 3 times 10, 3 groups of 10, if you wanted to say that, 3 times 10 equals 30, right? If I wanted to do 12 times 10, what does that mean? I have 12 groups of 10. So 12 times 10 is 120, okay? If I wanted to multiply 32 times 10, I have 32 groups of 10. So this would be 320. And you can keep going. You can make the numbers bigger, anything times 10. It's really that number, adding a 0. If you noticed, 3 times 1, 3 plus a 0. 12 times 1, 12 plus the 0. 32 times 1, 32 plus the 0. You're just adding that 0 at the end of it. So if I were to add 32, 32, 32, 32, 32, 32, 32, 32, blah, 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 10 times, it would be 320, right? So and again, we can check our answers. This would be that it was 10 plus 10 plus 10. This would be that it was, 12 plus 12 plus 12, 10 times. 32 plus 32 plus 32, and so on. So that's all that multiplication is. And when you're multiplying by just 10, it's that number, add that 0, okay? Easy peasy. Let me show you hundreds though. Okay, multiplying hundreds, just as easy as multiplying tens. If you're straight up just multiplying by 100, so using the same examples as before, if I did 3 times 100, that just means I have 3 groups of 100. So I would still multiply 3 times 1, add the 2 zeros. That would be 300, okay? If I wanted to do 12 times 100, still multiply 12 times 1, 12, plus the 2 zeros, 1,200. If I wanted to do 32 times 100, 32 times 1, 32, add the 2 zeros, right? So same concept, you're just making those groups. So again, it would be as if I did 3 plus 3 plus 3 plus 3 plus 3, 100 times. So you would literally just plus 3 plus 3 plus 3. Multiplying was someone's invention or way of cutting that down and making it quick. So we're just pulling tricks out of our sleeves and making math a little bit more fun and interesting. We didn't want to just add and subtract. We wanted to do these groups multiple times. And so that's what multiplication is. Hopefully this helps kind of understanding multiplying by tens and hundreds. But I'm going to show you a couple strategies of how to just multiply in general. And it goes from like easy peasy to like kind of complicated to what is Miss Diaz doing. So no matter where you're at, totally fine. Multiplication just takes practice in general. So let's get into it. Okay, I'm going to start with arrays. Arrays they just take a while. But if this is a strategy that works for you, that's okay too. I have 12 times 8. So I'm going to put one number, doesn't matter which way you do it, but I would put one number that is going to be vertical, and then one number that's going to be horizontal. So if I'm going to make an array, you would kind of make a box or a chart. If you're making an array, I would have 12 going vertical. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 8 horizontal, counting the same one though. 1, 2, 3, 4, 5, 6, 7, 8. Then you would actually fill in the rest of those dots. So making sure that you have 12 down in each category. And you would just make sure that you are making your dots of each one, keeping them super aligned. Just for the sake of a strategy, just showing you that this might not take, it might not be quick, but it is a strategy that you can use. And I have seen students do this. Again, it's okay. It's just, I would like for you guys to kind of pick up strategies that might be a little bit quicker. Okay. So now that I've made sure I have all of my dots, I would literally count them. So 12 times 8 is 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Just so I don't lose my place in case someone talks to me or whatever. It's always key to write down where you stop so that you can get someone's attention, or just so that you don't have to recount all of your circles, right? So I know that up to here I have 40. Okay. 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64. I'm going to just kind of pause there because I'm running out of breath. Whew. 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80. Okay, I have 80 here. 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96. All right. So I know that 12 times 8 equals 96. This is a strategy you can use. Totally fine. But let me show you more, okay? Okay, strip diagrams is just a visual for you to see what the problem is asking of you. So a strip diagram is also going to be like this long rectangular thing that you can draw it in your math journal or wherever you're working. And then it has two parts, a top and a bottom. We use these in addition and subtraction, and it's easy to see, like if you're subtracting, you would put the bigger number on top, you would subtract whatever number you were subtracting, and then you would find like the third piece / question mark, right? So that was like when you did subtraction. If you were adding, let's say you would add two numbers to figure out the total altogether, and that would be placed on the bottom. So for multiplication, we're looking for, you can either do this top or bottom, whatever works best for you, but you're looking for a big number. So I'm going to put the big number up at the top. This whole strip on the top is going to equal the groups that we're going to do. What would be easier? 18 groups of 4. Ugh, that would take a while. Or 4 groups of 18. It's the same thing. So instead of doing 18 like groups of just 4, right, I would have to do that 18 times. That would take me a really long time. I'm going to just do 4 big chunks and do 18, 18, 18 4 times. That's a strip diagram. That's a way for you to know what you need to do, right? So going from here, you would then just add 18 up 4 times. That's an option. You could literally just do that. Okay. Or you could split up each number 10 plus 8, 10 plus 8, 10 plus 8, 10 plus 8, and then add all of that up, depending on how wild you want to get with this. And then you could add like all the 10s up and then all the 8s up and then add it all up together. Whatever strategy works for you in terms of addition. I went through all of the strategies last week. You can always go back and, was it last week? The week before last, sorry. You can always go back and look at all of the addition and subtraction from Unit 2 and the strategies we use there. But a strip diagram really is just a representation of what the problem is asking. Once you kind of do your addition and get your answer, you can always just cross-reference and check with a different strategy. Okay, area models. I actually really dig this strategy. It's awesome. It's a great visual to use. It doesn't take as long, and it kind of helps break things down one place value at a time, which is what we've been learning. So 12 times 13 equals what? So what you do is think about your expanded form strategies from previous weeks. How would you expand both numbers? That turns into your visual. So like an array, you would form somewhat of a box. You're actually going to form like a rectangle, but you would put one number, it doesn't matter which one where, one number on the vertical side. Correction, sorry, I already messed up. You're going to put a set of numbers on the vertical side and then a set of numbers on the horizontal side. But here's the thing. It's not like a razor, you just put the number like I just did. Don't do that. You are actually going to split up one number at a time based on its place value. So ones in the tens, so I would put tens. Twos in the ones, 2. So looking this way, I have 10 and I have 2. I need to split up the other number though, okay? So ones in the tens place, so place value of 10, and 3 in the ones place. Now I have lines going this way. So it gives me a grid or an area model. What you do with this though, is you're going to multiply each number to fill in those boxes. This is how this works though. You are going to multiply the top number with the side number to fill in this box, the top number with the side first number to fill in the second box, the top number with this side box to fill in this one, and then the last two here. So I want you to just, this is somewhere where you can get a little mixed up or tricky. Stay within your line. So I'm not going to multiply 10 here and 10 here because we are not in that row. You need to make sure that you're multiplying one row or one box at a time. So to do that, you would just you can either use a paper, fold your like math journal in, cover this side of the box so that you don't get confused, or you can fold your paper, this way, or just cover it with your hand, but taking one box at a time. So 10 times 10, when multiplying tens, it's simple, just multiply the two numbers. It would still be, the 1, but then you would add the 2 zeros. So this is actually 100. Okay, I'm going to stick with the same 10, but move this way. 10 times 3, so I'm multiplying these two numbers to come here. 10 times 3 is 30. Okay, I have this whole row done, so this number is done. I'm done with multiplying that number. I'm not done multiplying this one though. 2 times 10 to figure out this number, 20. Okay, 2 times this number, which is going to come down here, 2 times 3. Again, you can look at a multiplication chart or you can do an array to figure that out, but if you don't know these by heart, it's helpful to just kind of make another, strategy off to the side. But 2 times 3 is 6. So now that I filled in my grids, step one was splitting it up into tens and ones or whatever, how many place values. Step 2 is filling in all of the boxes within your area model. Step 3 is now adding those all up. So I have 100 plus 30 plus 20 plus 6. Okay, then you're going back to your addition strategies. So I could add up however I want. I can do 20 plus 6, 26. 26 plus 30 is 56. 100 plus 56 is 156. You can do that however you want, but my answer is 156. So 12 times 13 is 156. Okay, so this is area models. Let me jump into a different one, but hopefully this helps. I really like this one, and this is a great one to practice multiple multiplications with. So yeah. So area models, otherwise known as box method. I'm going to run us through a double-digit multiplication and through a series of steps that you can follow just as a recap or a refresher for us at home. So if my multiplication, let's say, was 23 times 42, if I'm not ready for standard algorithm or equations yet, I can break this down into an area model using box method. So my first step would be to create my box. Make sure that your box is big enough for you to multiply or put things inside. I actually might have drawn this a little too small, but something that's large enough for you to split up into 4 parts. what I'm going to do is split up one of the numbers on the top and the other number on the bottom into tens and ones. So for example, 23, I could split it up for 20, and then I could add 3 more on the side and make my tens and ones boxes for that. And then I can do the same for 42. I could do 40 here plus the 2 that it has and split this up as well. So I'm going to change colors so you guys can kind of see what my steps are. So that was step 1, was creating my box. Step 2 was dividing those numbers into tens and ones on the top and on the side. Now that we've done that, we're going to go ahead and multiply these numbers to fill in those boxes in the inside. So this first box, I would be multiplying these 2 numbers. So I would take the 20 times 40 to get an answer. Easiest way to think about when you're multiplying tens is to multiply the 2 numbers at the front and then add the zeros at the end. So if I did 2 times 4, I can quickly know that that is 8, then add both zeros at the end. So this answer would be 800. That is not our total answer yet. That is just that first box. I'm going to go ahead and switch colors again. Stick with me. Throughout this step, you would go ahead and do each box. Now, for this next one, you would take the number that's on the side versus the number that's directly above that box. I am not multiplying the 2 because it is not on that row. So 40 times 3 to get this answer. Again, you can multiply the 2 numbers and I would get 12 and add the 0 at the end. So my answer in that box would be 120. Switching colors again, just to stick with me. Now, again, I would do the same thing for this column and this row. I would multiply 20 times 2, multiply 2 times 2 to get the quick answer, and then add the 0. And then last but not least, hopefully you guys can see these colors, 3 times 2. Oop, that's way too light. Sorry about that. Let's do red. 3 times 2, quick, easy answer would be 6. Now, so step 1, make the box. Step 2, divide the numbers into tens and ones. Step 3, multiply each box to find those small answers. You will get 4 different answers. Now my next step would be to add all of these up. So I would take the 800 and add it to my following numbers. So then I would get the 120 and then add up the 40 and then add up the 6. Okay, so that would be my next step, just to make sure that I get out of this space that might look like too much, and to simplify and just take out those answers to add those up together. It's too confusing if you try to do the addition along with the multiplication inside the box. Take it all out, whatever you need, and move forward. Our next step would be to then add those up as simply as possible. You can do it in a variety of different ways. There's no wrong way to do this. I could stack them all up and write them underneath each other and just add them all up at the same time, or I can add 2 at a time. It really just depends on you and what works best for you. I like to add them like this, so I know this would be 920 and this would be 46. Then this is easier for me to just add the 2 numbers, 920 plus 46, and then do simple math this way. So 6, 4, and 2 is also 6, and then 9. So my answer would be 966. Just to check my answer, I am going to do it again, but adding all 4 numbers down at the bottom. And I'm not going to go through the mess of markers again, but you get the idea. 120, 40, and 6. I can add all of those up just to check. 0, 0, 0 plus 6 would be 6. 0 plus 2 plus 4 would be 6. And 8 plus 1 would be 9, and I get the same answer. So hopefully this helps with understanding box method or area model. You can do this with any single digit number, as well as 3 digits versus 1. It's the same concept. You just need to make sure that you're going one step at a time. Yeah. Okay, so partial products just means taking this one step at a time, but not necessarily using a box or a grid or an area model. This kind of takes all of that away and just breaks it down for you in a different way. So let me show you what I mean. So if I take 324, let's say I want to do this like a standard algorithm, but I'm like, that looks scary. I'm not ready for that yet. That's okay. Hide the second number, break down the bigger number. So expanded form, it's 300 plus 20 plus 4. 3 in the hundreds place, 2 in the tens place, 20, 4 in the ones place. Okay, so we've broken that down. Then I'm going to multiply 6 times each one. That breaks it down easier. So I have 6 times 300, 6 times 20, and 6 times 4. This is way easier to break down because anything times like the tens place or the hundreds place, you're just multiplying that first number and then adding that amount of zeros. So 6 times 3, that's an easy one, would be 18 plus the 2 zeros. So that comes out to 1,800 or 1,800. 6 times 2 is 12 plus the 0. So that turns into 120. 6 times 4 is 24. Okay. I'm saying these quickly because I have those memorized. If you're not there yet, that's also okay. Use your multiplication chart as a reference, but you can break each one down from the hundreds place. Just add those 2 zeros. Add that 1 0, right? This one we don't add any zeros because there weren't any, because we're in the ones place. So once you've broken it down like that, then I can just put those 3 numbers underneath. I actually kind of did this backwards because really you would have done 6 times 4 first, so my bad. But we are going to put the 24 here. I got that covered. I did this backwards, but you would have 6 times 4 is 24, 6 times 2 or 20 is 120, making sure that I'm aligning these numbers. That's key and super important. Got that one. And then 6 times 3 or 300, right? Because that was that place value was 1,800. So boop, boop, boop. And I'm just adding all those up. And really, if you wanted to put these numbers first and the other way, that's fine too. It's just that when you get to standard algorithm, which is the quickest strategy, you would be putting the ones first, then the tens, and the hundreds. So that's my bad for doing that, but hopefully you get that. If not, ask me during small group. 4 plus 0 and 0 is 4. 2 plus 2 is 4. 8 plus 1 is 9. 1 plus nothing is 1. So my answer is 1,944. Again, this is what standard algorithm would actually look like, but this is partial products, meaning that we're breaking each one down. You know place value and you should know expanded form. So we're just kind of implementing those steps to make sure that we're understanding the process, okay? Yeah, let me jump into standard algorithm. Okay, so for standard algorithm, you actually end up using some mental math if you're wanting to do it pretty quick and if you have things memorized. If you're not there yet, again, totally fine. You can use your multiplication chart and take one step at a time. But for the sake of this strategy and practice problem, I'm going to show you kind of how to work this way. So let's see, 13 times 24. I need to stack them up one on top of the other. This might be confusing if you're not here yet, but I'm still going to show you, and I want you to just follow me and one step at a time. You always start with the ones place. You don't start on this side. Always go from, what is this, my right to my left, right? So if you're looking at the paper, you would start on the right side and work your way this way. You are always going to start with the bottom right number, and you're going to multiply up to however many numbers you have and be placing your numbers down. Then you're going to start with, then you're going to go into the second number, but we'll get there. So 4 times 3, moving up, is 12. You are actually going to carry that 1 up, okay? 4 times 1, anything that you carried up, you don't multiply, you add it. So 4 times 1 is 4, plus 1 is 5, okay? We're done with that row. Because we're going into the tens place, you need to add a 0 in the ones. We multiplied the ones place on the bottom. We need to now multiply the tens place, okay? So we add that 0 just to add that filler because we're not in the ones anymore. So now I'm going to erase or take away all the other things that I've done. So 2 times 3 is 6. Okay, 2 times 1 is 2. Then I'm going to add these up. You no longer need to look at these numbers up here that you're multiplying. You just need to add these two numbers that you've now created, 52 plus 260. Okay, 2 plus 0, and this is typical adding. So 2 plus 0 is 2. 5 plus 6 is 11. Carry the 1. 2 plus 1 is 3. My answer is 312. Some of you might be looking at this and being like, what just happened and what did she do? That's okay. This takes practice and we will get there. But I'm going to erase this really quickly and just show you with a 1-digit number. Maybe that'll be a little bit simpler. I wanted to show you what 2 digits times 2 digits. And again, that can be used in an area model, an array, any of the strategies I just showed you, but let's do another one just for kicks. So let's say we multiplied, I don't know, 15 times, give me a number, I don't know, 4? Sure, okay. So 15 times 4, again, I would stack them up on top of each other. I have nothing in the tens place, so we're just making that one number. So 4 times 5 is 20, leave the 0, carry the 2. 4 times 1 is 4, plus 2 is 6. 15 times 4 equals 60. That's just with one number. You're multiplying it with one number, right? See how the steps kind of change when you add that second number or the what is it, the tens place? So let's say times 14. It adds a little bit of, it adds a layer, right? So 4 times 5 we know is 20. Carry the 2. 4 times 1 is 4, plus 2, anything you carry, you add, is 5, 6, so I have 60. Add the 0. When you have a second number, you need to add that 0 underneath to give room for that ones place that we are not multiplying anymore, okay? 1 times 5 is 5. 1 times 1 is 1. I'm going to add these two numbers at the bottom. I no longer need to look at this. 0 plus 0 is 0. 6 plus 5 is 11. Carry the 1. 1 plus 1 is 2, is 210. I added that second step because I have that tens place. Here we just had the ones place, so it was pretty simple. I can double check my answer for this one by doing, let's say, an area model. 10 and 5, because 1 in the tens place, 5 in the ones place, make that over. Times 4. I don't have a second number, so that's it. 4 times 10 is 40. 5 times 4 is 20. 40 plus 20 equals 60. So I just checked it with the second strategy. Strategy 1, strategy 2 for this one. So, and again, you can do the same thing for that one. Split up 10 and 5, 10 and 4, multiply it all out, add it back up. It should come out to 210. Mental math comes in handy, makes this process easier. If you're not there yet, again, please use a multiplication chart. But yeah. Okay, this is a bit of an extra, but I think it's fun just to know. You're not going to be quizzed on any of this, but I think it's worth at least just being mindful or in the know of. Perfect squares just mean when a number is like multiplied by its same number. So 1 times 1 is 1 squared. Meaning, if I were to draw a square of that being multiplied, it's 1 square, 1 times 1. That's it, right? So when you would represent that, it would actually, let me change my color. It would be shown as 1 with a little 2 above it. 2 with a little 2 above it, 2 squared. 3 with a little 2, 4 with a little 2, and so on. And you can go the whole list. But it just kind of shows, it would let you know that you're multiplying that by the same exact number twice, okay? So all that being said, 1 times 1, 1. 2 times 2, 4, 3 times 3, 9. These I have memorized. 4 times 4, 16. 5 times 5, 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. Let me see if I can remember these. 9 times 9 is 81, I believe. 10 times 10 is 100. 11 times 11, I'm thinking, is 121. I feel like I'm being quizzed. 12 times 12 is 144. I'm trying. I think 169. You can maybe quote me on this. If it's wrong, just let me know during small group. And then 14 times 14 is 196. I think it's 196. I don't know. If I made a mistake, let me know. Give me the feedback. I think I got these right. But these are perfect squares. So it's as if I were to literally map out 14 little tiny squares out, right? So let's take a smaller one, for example, 7 times 7. It's as if I literally made 7 squares this way. 1, 2, 3, 4, 5, 6, 7. Okay. So 7 here, and then it would be 7 down. 1, 2, 3, 4, 5, 6, 7. So you would make like a graph, almost like an array. You could make an array, or you can make an area model. You can do whatever strategy you want to multiply these. But 7 times 7 just means that I'm multiplying 7 squares down by 7 squares across, and there would be 49 total squares. That's what each of these mean, that you're taking the same amount across and the same amount down, and you would count those grid squares to get your answer. Okay, so perfect squares are just fun to know. And again, they kind of are fun to write because they have a little tiny 2 on the top right corner. Again, just extra, but thought I'd share. For area models, you have strategies such as strip diagrams, reverse box method, and a couple of others. But I'm going to show you one today that should be simple if you like to see things visually and understand place value, as well as base 10 blocks. So I'm going to be using the same problem for all 3 strategies in this Bath Math video. And here are the numbers, but let me read you the problem just so you understand the numbers. So Liliana has 432 cookies to share with 3 of her friends. That's a lot of cookies. But if each friend gets the same number of cookies, how many cookies does Liliana give each friend? So she has 3 friends. She wants to split up the 432 cookies into each of the friends. So the first step I'm going to take is draw out the place value blocks. And if you understand base 10 blocks, we have our hundreds place value, tens, and ones. You could also do this with thousands, but I'm going to stick with these 3 for now. So in the hundreds place, I have 100, 200, 300, 400, okay? In my tens place, I have 10, 20, 30. And in my ones place, I have 1, 2. Okay, so I've drawn out my place value blocks. Step 1 is done. You no longer have to do that again. Step 2, 3, and 4, however, are repeated multiple times for each place value. Okay, and that is what step number 5 says. It just says repeat steps 2 through 4 until you've divided the entire number. So these are really the meat of this strategy. Okay, so I'm going to start with the first place value, which is my hundreds. I'm going to circle groups of 3, and really you can insert any number here that would be what you're dividing into. So for a problem that says 5 divided into whatever, you would circle the groups of 5, or if it said 2, then you would circle the groups of 2. So for this problem, it's 3. But I'm going to circle the groups of 3 in the first place value. I have 1, 2, 3, 4. I am going to circle the group of 3. Okay, and again, like I said, this is repeated each place value. Do not go circling the 10s and the 1s right now. That is not what we need to do. We need to do 2, 3, and 4 in each place value, so just remember that. The next step is to record how many groups of 3 there were in that place value. I only had one group of 3. There are no more hundreds to circle, so it is just one group of 3. I would record that on top. I have one group of 3. Regroup the leftovers to the next place value. I have 100 left over that I cannot put into a group of 3. So I'm going to cancel it out here in the hundreds and regroup it into the tens place. But I cannot put the hundreds base 10 block in this column. I need to separate it into base 10s, blocks of 10. How many blocks of 10 are in 100? 10. So I'm going to cancel it out here and regroup it into this column. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, I've done 2, 3, and 4 for this first column. I'm going to go back up to number 2. In my place value of 10s, I'm going to circle groups of 3. So I have 1, 2, 3, 4. Record how many groups of 3 were in that place value. I have 4 complete groups of 3. I'm going to record that. Regroup the leftovers to the next place value. Okay, I have a block of 10 left over. I need to regroup it into the 1s. I cannot just move the 10 over. I need to actually draw the 10 1s. So I'm going to cancel it here and draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, for me it helps to say it out loud so that I don't get confused and that I'm not mixing it up with the blocks that I had drawn from the beginning. Okay, again, I'm going to go back up to step number 2 and repeat, circling groups of 3. 1, 2, 3, 4. Record how many groups of 3 were in that place value. There were 4. Regroup the leftovers to the next place value. Do I have any leftovers? No. Is there another place value? No. So I don't need to do that anymore, and I don't need to do step number 5 anymore. I have divided the entire number. So I am done using these steps for this strategy, and I have my answer. You can always go back and make sure that you've done it correctly by trying a different strategy, but I'm hoping that seeing the place value and the base 10 blocks underneath is helpful to you. Good luck. Okay, using the same problem, I'm going to read it again. Liliana has 432 cookies to share with her 3 friends. If each friend gets the same number of cookies, how many cookies does Liliana give each friend? So what I've done, we're going to use a strategy called partial quotients. And what I've done on the side is just written down some facts of 3. It would be helpful to do this in your math journal when working on a problem. Multiplication is very much tied to division. So when you have the number on the outside, it's helpful to write down some of their facts off to the side just so that you have them ready to go. Or if you have a multiplication chart, just maybe covering up the rest of the chart just to see that row. So with partial quotients, let's break that down a little bit. Partial meaning parts, quotients meaning the numbers. And instead of we're not using standard algorithm just yet. That'll be the next strategy. But for this, I want to take out numbers of groups. So what does that mean? First thing I'm going to do is create just a long line here going down to make a barrier or a wall for my numbers. On this side, I'm going to have the number of groups taken out that are going to be going down this side.
Make sure to line those numbers up because you will be adding those numbers up and that'll be your answer. What we're going to do on this side though is the messy stuff, subtracting, okay? And so on this side we're going to be adding to get our answer, but on this side we're going to be subtracting parts or groups out of the total number, okay? So for example, and here's the thing, you could do this exactly the way that I'm doing, or you can use different groups. It really doesn't matter as long as you're doing the math correctly, meaning in terms of your multiplication and then your subtraction. So for example, the first group that I want to take out, I want to take out 100. So if I took out 100, a group of 100, I would multiply 100 times the outside number, times 3. So that answer, 100 times 3, gives me 300, okay? That is going to be the first thing that I subtract. What does that leave me with? 2 minus 0 is 2, 3 minus 0 is 3, and 4 minus 3 is 1, okay? Now I still have 132 cookies out of my total, right? So far, each girl is receiving 100 cookies, but I still have 132 left. So I need to take out another chunk for each girl in the group. Let's say I think that I can give each girl 20 cookies. I think I can afford to give each girl 20 cookies and not have gone over. So I'm going to try that. Let's say I give each girl 20 cookies. 20 times a 3, friends. 20 times 3 gives me 60. Going to subtract that. 2 minus 0 is 2. 3 minus 6, not enough. I'm going to cancel the 1 and carry that over to make this 13. 13 minus 6 gives me 7. So now I still have 72 cookies total to split up into the 3 girls. If 20 gave me 60, or 20 for each girl gave me 60 to subtract, I think I can actually do that one more time. So I'm going to try doing that again. And I'm just going to change colors just so you can see the steps that I've taken. So I'm going to try giving each friend 20 cookies again. 20 times 3 gives me 60. I already have my facts here, so I can just quickly check that. I'm going to subtract that total. I would get 2 minus 0 is 2. 7 minus 6 is 1. I have 12 cookies total. From the beginning, I've already split the girls' cookies up, so each girl got 100, they each got 20 again, and then they got 20 again, right? But I still have 12 left over. Now, what is a number that can go into 12 evenly? From our facts, it could be either the 3 times the 2. I could do that twice, or I can do 3 times 4. That is also a fact. I didn't write it down here. Either way is totally fine. Again, you could just do the 4, or you could do the 2 twice. So I'm just going to use the facts that I have here just to make sure that I'm okay. I'm going to give each girl 2 cookies. 2 times 3 is 6. I'm going to subtract that. That gives me 6. I still have 6 left over. I can do that again. I'm going to give each girl 2 cookies. Multiply it times 3. Subtract the 6. I have 0 remainders. That's not the last step though. So now that I have 0 cookies left to pass out, how many cookies does each friend get? Right? Now I need to be adding these up. So I have 100 plus 20 plus 20. You could add a few numbers at a time, or I can add them all together at the end. So what I'm going to do is just show you both ways. Do this simply. 2 plus 2 is 4. 20 plus 20 is 40. So if I were to add 40 plus 4, that give me 44 here, plus 100, that would give me 144. I can also check this way, right? So in the ones place, that would be 4. In the tens place, that would be another 4. And in the hundreds place, 1. So this is my total number of groups. Each friend gets 144 cookies. Seems like we got the same answer as strategy 1. Hopefully this helps as well. Okay, last strategy, standard algorithm. I believe this one to be the quickest. Once you understand the steps and have practiced multiple times, Any 3-digit, 2-digit, 4-digit number that you divide should come easily when using this method if you're dividing by a 1-digit number. Once you get into 2-digit numbers, it gets a little trickier when you're having to separate or know what numbers to break it into. But for this sake, in this problem, I'm going to show you with the 1-digit. So again, it's the same problem. Liliana wanting to share her 432 cookies that she's made and dividing them into her 3 friends. So the first step I want to do is separate or cover the place values. If you are doing this on paper, grab a different sheet of paper and cover the place values that you don't want to divide into yet. Or you can also just draw a line. So I want to divide 3 into the first number. I'm just going to cover or separate these 2 just so that I kind of get them out of the way for now. Step 2, I'm going to count the number of times that this number goes into this one. So how many times does 3 go into 4? It goes in 1 time. You're going to write the number on the top. You're not done with that number yet. You need to multiply and subtract. So I'm going to multiply 3 and 1. And I'm going to put it underneath the number that I was putting it into. I'm going to subtract. 4 minus 3 is 1. Next, you're going to bring down the following numbers. So this 3 is going to come down and sit next to the 1. So instead of having just 1, I have 13. You can continue to separate with the line or with your paper covering that 2. Don't worry about it for now. What I did is just bring down the next place value, and now I have 13. So going back to step number 2, how many times does 3 fit into 13? You can use your multiplication chart, you can count with your fingers, or you could have the multiples of 3 facts written down somewhere in your journal off to the side, but I have memorized 3 times 4 is 12. So I'm going to put the 4 up here, multiply, gives me 12, and I'm going to subtract. Notice that if I had done 3 times 3 is 9, it would have given me a different number. That still works fine. But had I done 3 times 5, it would have given me 15 and I wouldn't have been able to subtract. That wouldn't have been helpful. So make sure that you do not pass the number that you created. So out of those 2 numbers, so I have 13 minus 12. Again, I have 1 left over. I still have that last place value there. If you uncovered it or if you separated it, now is the time to bring down the next number. So I have the 2, I'm going to bring it down to be next to the 1. It creates or turns the 1 now into a 12. Same steps, count the number of times this number goes into this number. I had used 4 times 3 and it gave me 12. So again, multiply. That's this next step. 4 times 3 is 12. And then subtract. So 12 minus 12 is 0. Bring down the next number. There is no next number. So I am done with that. There are no remainders. And again, using strategy number 3, I was still able to get 144. Here are some extra tools for working on division. I hope that they help support you and bring a little bit of your classroom into your home. These are tools we would have used or anchor charts we would have gone over in class together. This is a great time to pause the video and check each one out.